Introducing Portraits and Ideas. I'm Erlinus Gao, presenting interviews to inspire and perhaps unveil something new in the realm of ideas. I would like to introduce you to Professor Helmutt Pottmann, who is a professor of mathematics and computational science at KAUST. Could you give me your professional position in KAUST?
Yeah, at KAUST I'm a director of a research center which is entitled Geometric Modeling and Industrial Geometry, and we are at the interface maybe between mathematics and computer science and to some extent art and also engineering, so it's a challenging area of research.
That sounds like quite an exciting panoply of subjects that you can sort of pursue in an interdisciplinary way.
Yeah, this is quite clear because we are, for example, dealing with visualization, and visualization of data can come up in almost any field, and visual images can give more insights than just numerical data. So in German we have the saying that one image says more than 1,000 words. And actually I think a good visualization should say more than many images. So this is our goal, to facilitate the interpretation of scientific data.
As we start our discussion here, what advice would you give to the youth in Saudi Arabia to promote their interest in pursuing science careers?
I would advise to start already in high school to get interested. A career in science may consist of several factors. One is of course the motivation, and I know from my own experience that the best motivation can be if you have a good teacher in high school, you get interested in high school, and then you may pursue such a career. So I think it is already related to high school.
Mm-hmm. What about an earlier age than that? I mean, when you...
You're right, it starts in the early childhood.
Sure.
It starts in the early childhood. So my parents tell me that when I was very young, maybe 3 years old, I could already do some painting, and I was very good in making 3D models. Mm-hmm. And in fact, after I was then very interested in both actually art and geometry and mathematics in high school. And after high school I wasn't sure what to do, go more into science or more into art, so I applied at art school, but I was very lucky to get rejected. And so I entered the field of geometry, which I still believe is a fascinating field, which especially now with the advent of computers has become much more interesting. When I was studying in Vienna many years ago, we still had to do all these constructions with ruler and compass, and now we have these powerful computers, especially here at KAUST, so we can do things which have been totally impossible years ago.
Well, that leads us to the question, why did you decide to come to KAUST?
This is a good question, and somehow I stumbled into the whole thing. So I was contacted by an international search committee whether I would be interested, and so also originally knowing nothing about, actually almost nothing about Saudi Arabia and definitely nothing about KAUST, I got interested because there have been some really big names on this search committee. And so I asked to hear a little bit more about the details, and at some point I was invited to submit a CV to this committee, and so I submitted a CV which was barely ready because really I was determined to stay in Vienna. I didn't even have a complete CV, so I had to prepare something in a rush. And for some reasons they invited me to London to be interviewed, and all president, vice president, so all the high people, high management of KAUST has been there. And to my big surprise, after maybe 1 hour I got the feedback that I will have an offer within a few days actually.
So it's quite a journey. what apart from the names of the people on the committee who made a decision to
Well, they had an
what attracted you? What about KAUST attracted you to this academic institution that at that point
Yes,
it
yes.
didn't exist?
Exactly. So I relied only on information available at the web originally, up to the point when I got actually my offer. But of course, I didn't sign immediately the offer, so I spent enough time to think about it. And maybe you remember, we jointly toured through Saudi Arabia. We
Sure.
saw the country. We got more information about KAUST, and I realized that this is really an excellent chance in my career to try something totally different, to see how a university emerges basically from the sand of the desert. So nothing has been here before. I am coming from a university in Vienna which has a history of almost 200 years, and this is totally different. And I was convinced that here the structures are probably not yet that rigid as they are at other universities, and the facilities are outstanding. You cannot compare with many other places in the world. And I think there's a specific type of people who join KAUST, and this was actually my biggest hopes, that people seeking some adventure like myself,
That's right.
and people who are open-minded and want to do something totally new. And therefore, I believe this is an excellent chance to do things which I would never have done back in Vienna. So that's mainly why I chose KAUST.
After you got nominated, you came with a group. Did you find that among the people that were in the group that you originally came with to tour Saudi Arabia and look at the site of construction of KAUST and to get an idea about what life would be like in Saudi Arabia?
Once again,
When you first came, you came with a group.
well, I came with a
And
group.
when you were making your decision about coming to KAUST, how did you find that kind of personality in the group that you just
Exactly,
described?
yes, I was totally confirmed. Actually,
right.
when I came with this group, I had already made up my mind, basically.
Sure.
I was sure, actually,
Right.
to join, and I found this totally confirmed.
And the people you met, as well as the information you received,
yes.
was a confirmational
Yes.
kind of thing, which is quite interesting. How did you reach the position you're in today in your profession? Please outline your career and explain the milestones in your educational advancement to the PhD.
From the beginning to the PhD, no, from the PhD to now, right?
Actually, when I say to the PhD, and I mean after the PhD as well, because obviously you have had a considerable career after your PhD, but those milestones will be instrumental and instructive to students who might be considering pursuing a career like yours.
So I must say I was very fortunate. My parents put a lot of emphasis on education. My father he's still alive, but he's now a retired teacher, so he was a teacher, and I had three brothers, and all four of us, we were very much encouraged to study really well. So after finishing my high school at home in a small town in Austria, I went to Vienna as I said before, to try art school, but I didn't get in, so I went to technical university and entered mathematics and geometry. In Austria, geometry can be studied as a separate subject because it is also a separate subject in certain high schools. So I focused already at this time on geometry. There I could actually finish my studies, so my master within the shortest possible time, and 1 year later I had the PhD, and a few years later, maybe at the age of 26, I got the habilitation, which means a permanent position at Vienna University of Technology. But since I reached this so early, I decided to leave the university. In Austria, there is no chance to be promoted to a higher level from if you have done your PhD at the same place. It's the same probably in most other parts of the world. So I made some experiences in Germany. I had a visiting position at Purdue University in the US. And then I got my first professor position in Hamburg, in Germany. I was around, I think I was 30 when I got this position.
That's very early.
It's quite early, yeah.
Very impressive.
And then I was even more lucky because I got a full professorship in Vienna at the age of 32. And that's actually the position where I have been until joining KAUST, and I still keep some affiliation with my university back in Vienna.
Mm-hmm.
And I could actually return if I want. So
Sure.
to say.
That's a very rapid rise in the academic structure and of all these different universities you've been to. What do you attribute that rapid rise to? How do you explain that? That's not typical.
Good luck. I think it was a good deal of motivation.
Yeah, okay.
And I think one thing is the following: that I received my training actually in an old field, but namely this kind of descriptive geometry, classical geometry stuff, which is an old and to some extent outdated subject of studies. But I learned a lot of methods which make sense, especially in connection with computers, and this hasn't been done before. So I realized when merging this knowledge with modern developments, so in computing, this may be a good way to have success, and I was very lucky that this was a good decision.
Create something new.
Yes.
In other words, you had tools that Euclid didn't have.
No.
For example,
yes, yeah, you're right.
For example.
Yes, exactly. But I wouldn't compare myself with you.
Well, in any case, why geometry? I mean, okay.
No, this was very natural for me.
Yeah.
Because for me, geometry is somehow, especially if you do geometry in 3 dimensions, and if you always have some visual component in your geometry, it is very, it helps you a lot if you have a good imagination, a good spatial imagination. And remember, I told you I wanted to study art, so I really like shapes. I like to build aesthetic shapes and so on. And I think geometry is the natural choice. So I'm not so fascinated by just numbers. In fact, I'm really poor in remembering my numbers. Mm-hmm. And when you ask me my office number here, I don't know it. You ask me my phone number, I don't know it yet.
This is a typical professor,
but I'm in my office just for a few days.
Right. Well, it's interesting. I mean, because clearly geometry is one of those subjects that most students relate to early on in their math career as being the one where they really had to begin to think and to really solve a problem and to sort of get out of the rote memory process. And so that's the beginning of the thinking in math, we might say, in geometry. Eh?
It has some truth. Yeah,
especially proving theorems and so on. Yeah.
You can use different methods. You do not have to rely only on purely algebraic manipulation. You can also have nice synthetic arguments to prove something in geometry.
Sure.
Also, it's dangerous because sometimes the imagination may be misleading and your proof may be utterly wrong. Yeah.
That's right. That's right.
I also think that geometry has an advantage in combination with programming, because if you do some simple program, if you learn programming, and the result is just some numbers, it may be difficult for you to see what has been wrong. Mm-hmm. It may be even difficult for you to realize that the numbers which you get as output are wrong. Mm-hmm. But if you do geometry, you program some geometric shapes, you see immediately what is wrong, and you see whether it is wrong. So it is actually a good way to learn.
You have a visual confirmation, if you will.
Yes,
that's right.
Yes.
And actually, Professor David Keyes in your department, he made a statement yesterday that was quite instructive. He said that half of our brain is devoted to sight and sound.
Confirms.
Yeah, it confirms how important something visual will have in solving problems, and as well looking at designing new things and so on. Just a quick thing, I ran across a classical paper written by Raymondrahman. Is that one of the more recent people in geometry who I think Einstein used some of his ideas? Is it Raymondrahman? I'm not pronouncing his name correctly. Riemann. Raymond, yeah. And it was, I think, I'm trying to ask maybe about non-Euclidean geometry. Was it?
But the non-Euclidean geometry goes actually back to the time of Gauss.
Okay,
Yeah,
okay.
so this is
Okay.
Gauss and Hungarian mathematician Bolyai and others. So it arose actually in connection with Gauss's work on surveying.
Okay.
And in connection with his studies on differential geometry.
That's the French mathematician.
Yes.
Yeah, okay.
No, that's a German mathematician.
German Gauss. Oh, okay.
Carl Friedrich Gauss. Yeah.
Okay, Friedrich Gauss. Yeah, that's
Carl
right.
Friedrich Gauss.
Mm-hmm.
And I think he can be considered the inventor of non-Euclidean geometry to some extent, but he didn't even dare to publish exactly what he had found, because people would criticize him heavily.
Okay,
yeah.
so my questions might not be, how should we say, at the level of deeper understanding of the subject, but I think I'm trying to relate this mathematician Raymond regarding geometry on curved surfaces.
There I would also cite Gauss.
You would go back to Gauss.
And
Okay.
the French school. So in geometry there is a very strong tradition both in France and in Germany. Yeah.
Okay.
Yeah.
What would you say, obviously in your career you have run against difficult situations where you found material that was difficult to understand. What would you say would be the relative advantage of hard work versus high levels of intelligence in terms of accomplishing your goals in your work?
It is always a combination, I think. Without hard work, even the most intelligent guy may not get results. Mm-hmm. Also, I believe, basically, I'm not even so sure whether it is only intelligence. I think it is creativity. Mm-hmm. So, especially in my field, I think you have to have some strong creativity to look at the right problems in the right way. This I consider a part of creativity. Mm-hmm. And then it is a lot of hard work as well. Mm-hmm. But hard work alone, in my view, and in my field, may not lead to sufficiently interesting results.
Why?
Just
this is
a very old field, yeah. And we are doing it just with our brain. We do not have new lab equipment which wasn't around thousands of years ago. Of course, we have the computers. This is the only thing we have now. People before did not have. But still, I think the field is already sufficiently advanced so that mainly you get good stuff out through good ideas. Here in KAUST, I also hope to get good new directions out by collaboration across boundaries of fields. So this is another thing.
Mm-hmm. Explain that a little bit. Why KAUST would offer you this idea of collaboration with people in other fields more so than, say, other universities?
This has to do with the structure at these old universities. It is the most difficult to work with somebody at the same university in the same field. So I prefer, if I work in mechanical engineering, I work with the University of California. I do not work with our mechanical engineering department. I think there may be even some hesitations in the same university to cooperate. I don't know really why.
Because of rivalry between departments?
Yes, it can have political reasons, basically.
Sure.
So
you think KAUST will be a different model?
I think so, yeah.
Mm-hmm. In that
because the same, they will all have this motivation to work across boundaries, and KAUST is not covering the entire spectrum which an engineering school or a science school would have. KAUST is focusing on some really very, very new and important technologies. And having really the best equipment for those technologies, and therefore I think KAUST is the best place, and they will have the best data simply because they have the best equipment to get the data. Yeah.
And you say certain technologies and focused on solving key problems that exist in the world.
Yeah,
that's
key
right.
problems in the world, and especially, of course, in the region. Yeah.
Sure. When did you decide in your career to become a science researcher, academic person?
Yeah, when I started my studies in Vienna, I was actually registered as a candidate for high school teacher, so I was doing the curriculum for a high school teacher in mathematics and descriptive geometry. And then when I got my master's, during the work on my master thesis, I realized that actually I'm much more interested in doing research. So I was very lucky, my professor gave me a really tough topic and I had to create my own ideas on the topic to fill these 50 or 60 pages, which was required at that time for a master thesis. Mm-hmm. And so I had to invent something. And I started to really enjoy it. And professor liked it a lot, and so I got immediately an offer as an assistant position even before I had finished my studies. And so
for your bachelor's degree?
No, for my master's.
For your master's.
There is no bachelor in Austria. At that time there was no bachelor.
Okay, you went straight
to the master. This was the only way. Go to the master, and after the master you take the PhD.
Okay, that's the system in Austria.
This is a European system. Just now it has changed, but this was the system for many years.
And so that prompt, if you will, from that particular professor was a key.
I think so, yes, I think so, yeah. Mm-hmm. I may have ended up in some high school, and I could imagine I may be frustrated. I could imagine, yeah.
Right. Yeah. Well, I mean,
it depends.
It shows you the importance of a professor
yes.
who can spot talent, if you will. And he obviously spotted talent in you at an early point in your career, and he gave you some direction.
Yeah, right.
And it stimulated you.
When I wrote my first paper, I barely dared to show it to him. I just wrote the paper, yeah. And I gave it to him, and 1 week later he came back with a totally rewritten paper, but remember, this time this was done by hand, so he had totally rewritten the entire paper, and he offered me that he will publish it in the proceedings of the Austrian Academy of Sciences, so I was very happy to have this initial success.
This was before the master's?
Actually, it was on some claim which one could find in one of his books, which turned out to be wrong. So even in this case, yeah, he liked it a lot, and I had a new idea.
So even though it might have been something that ended up being, quote, wrong, it demonstrated a way of thinking and a way of approaching a problem, which was obviously very impressive to him. For him to spend the time with that, to revise it.
My writing was very bad, obviously, for him, yeah.
So was that after the master's or before the master's degree?
It may have been before the master's degree, at least at the time when I was working on the master's.
And that was the time when you were really formulating your thoughts about pursuing this career?
Absolutely, yeah. Then I was determined to try the academic career. Mm-hmm.
Yeah. What were your childhood stimuli to becoming a scientist? When you go back earlier in your life, you mentioned that at 3 years of age, your parents recognized your ability to do paintings and to build things in three-dimensional structures and so on. What else in your childhood really was a great stimulus for you?
Maybe the environment in our family. I mean, my father, he was a teacher in mathematics, in chemistry and physics, so it was quite naturally brought to us. We got all this encouragement from the parents, and I did a lot of experiments with my brother, who also became an engineer. He's in electrical engineering. Actually, we are 4 brothers, and 3 went into engineering and 1 into agriculture. This already shows a little bit that the family, I think, was the most important.
All science, all science. There's no coincidence, an accident. It was a very, how do you say, powerful influence of your father.
Yeah, I think so. Yeah.
So would you attribute, say, your ability in math? For example, math is generally considered by many students to be a tough subject and one that, you can run into a stone wall, and many students end up leaving the subject because they run into difficulties. Well, how do you explain your success? Obviously, your father gave you some encouragement.
There must also be something with, you are lucky, you
natural
have some
ability.
kind of natural ability.
Sure. But even with natural ability, you're going to run into situations where you're going to have a problem you can't solve.
Oh,
So
yeah,
what is
all the time I run into problems which I can't solve.
So then what is your strategy when you run into a situation? Because the reason I'm asking you this, a student out there is going to definitely run into that situation, and then we don't want them to give up. We don't want them to run away, and we don't want them to say.
A good student in mathematics will all the time run into problems which he or she doesn't understand.
Okay, so what's your approach? What is your advice to a student when they get into a situation like that? What should they do?
Keep thinking about the problem. So
Okay.
in my research, I formulate the problem, and initially I can't solve it, but I try to think about it. Every second day, every other day, something like this, if it is an important problem, maybe just for a short period of time, and then sometimes it happens that even if I don't think right now about the problem, I may be just walking in the forest or so, not even thinking about the problem, suddenly I have a good idea, it pops up. I think you have to bring it into your head, and exactly,
in your subconscious,
exactly, and then it starts to work.
Right.
And it may generate the solution or not, and it doesn't always work. But
Sure.
it really
Do you
works.
always need a piece of paper when that happens, or you can do it just mentally?
Both is possible, but actually sometimes it is very helpful to draw a good figure. Yeah.
And you find using the technique of diagrams and drawings as a way to facilitate your thinking process.
But really, also sometimes it just pops up for some mysterious reason, which I don't know, but I'm lucky sometimes I have this good idea then. But the problem needs to be in your head. If you don't manage to get it into your head, you will not get anything out.
So how do you get a problem in your head? You just, because actually that's one.
I tell you my strategy,
Sure.
how I was doing it back in Vienna, and I plan to do the same here. I start my morning spending at least 1 hour by thinking about research problems. I do not immediately go to office, look into email, maybe bad messages and so on. If there are good messages, I will be happy even later to read them. And if there are bad messages, it's much more productive not to see them immediately. So, and I found out that the morning time is the most creative for me. So I try to start every morning by doing some research, maybe just 1 hour or just half an hour. But it's important to keep the problems in my mind, and then during the day or something, I may come up with an idea.
So that's a good strategy that any student looking at this and listening to your advice can actually implement that strategy immediately. In other words, you wake up in the morning, you think about a given problem.
I get the breakfast,
Sure.
I relax
Sure.
think about the problem.
That's right.
Sometimes I sit even in my garden, I'm sitting in the sun, my neighbors may think I'm doing nothing, but in fact I'm thinking about the problem.
That's right.
Yeah.
That's right. That's a scientist method.
Yes.
And you take the early morning as a way, because
I found
once you go into the routine
Yes.
of other things, in the back of your mind things are happening.
But this may not work for everybody.
Sure,
As you know, some people are morning people like myself,
Sure.
and others are evening and night people.
Correct. But no matter what time of day someone implements it, they can take this idea.
Find your best time. And try to reserve this for research.
Exactly.
And I also think it is not good to work on the problem for hours. It doesn't help too much. So if you get stuck, just do something else.
Okay. And then get your mind off of it. Get your mind off of it.
Yes,
and in the meantime, your subconscious is kicking in and doing work, and then you're doing something else productive, and then you come back to that later with a fresh outlook.
Yes.
Yeah, and with presumably a fresh set of ideas on that problem.
This is an advantage of KAUST. You can go along the beach and think about nice things.
That's right. A lovely beach on the Red Sea.
Exactly.
You can be inspired by that for solving problems.
Actually, another thing is for me having a wide view. So if I sit in a narrow room and I think about the problem, a room without windows, for example, it's very bad for me.
Right.
So if I have a wide view, it's good. So I'm very lucky here. I have a wide view both from my house and from my office.
That's right. We've had some interesting discussions about that previously, and I can understand that contributes to the creative process in your work. How much time daily did you spend learning the skills that help you the most in school? I mean, and what were the skills that you found to be most important for you?
You mean in high school?
Yeah, going back to the earliest memory you had
Elementary school,
when
you
you were
don't do much. You go home from your school, you
Yes.
do your homework, which takes you less than an hour,
Okay.
and then you go playing. Maybe
Okay.
I was doing a lot with my brother, who's just 1 year younger,
Okay.
and we did a lot of, how to say, construct small things.
Right. Working as a team.
Yes,
Building things.
Yes, building things.
Right.
Small,
So that even though that was an assignment from school, that actually contributed to your, how should we say, advances
I think so.
in your thinking and
I think so.
now as you go up the ladder in your education.
I think another thing is music. So when I went into high school, or even earlier actually, in elementary school, my parents, especially grandparents, they liked me to study some music instruments. So I went into piano and cello. I was pretty bad in piano, but better in cello, so I really liked it. And I think it's also a very good mental training and the training of concentration, because you have to concentrate both on the notes, and for a string instrument, this is not so easy. So you don't just press a button and the correct sound comes out. So it is a training of concentration. So I enjoyed it a lot. And in advancing more in high school, I then joined what is called a mathematical Olympiad. I'm not sure whether in Saudi Arabia it's also around.
There's a competition. It's an international competition.
Yes.
And we actually hope to develop a program at KAUST for students to come in and train for the Math Olympiad, which is an international competition that goes on every year. And you actually...
I didn't do really well, but only on a national level. But
sure.
I learned a lot. I think you get really tough problems to work on, and you learn something.
It was a stretch.
Yes, you get some problem-solving abilities. Yes.
Let's go back for a minute to the music. Do you see a relationship between musical talent and mathematical talent?
I just know many mathematicians who are excellent musicians.
Exactly.
Whether there is a relation, I don't know.
Well,
it could be.
There's some research actually. The reason I ask is because I've seen research which shows a strong connection between children who learn musical instruments and their capabilities in math as being quite better than those students who did not have the exposure to music. So perhaps there are certain connections in the brain which are similar. There are similar pathways in the brain.
Maybe it helps the networking in the brain.
Certainly. That can promote your ability in math. That's another tip that students can perhaps learn something from. What circumstances did you see that were the highest risk when you were growing up to not achieving your goals of becoming a science researcher and to being a good student? And how did you overcome those risk factors, obstacles that might have been in your way potentially?
I mean, the biggest frustration or the most difficult situation in my whole life maybe was after the second year of studies in Vienna, when I had probably done too much. I was totally exhausted. I was almost finished with many classes in mathematics, and so I had done too much. And then during the summer I was doing some teaching, and I realized this really drives me crazy. And I got really problems. I had to go to hospital, and I had to stay there for actually maybe more than 1 month. I got delayed in my next semester at university. So this was burnout. At this time, this was not around the name burnout, but it may have been something exactly like this. And this was really a critical phase.
It points out the need for balance.
Yes.
Right.
Yes.
When you're working hard and you're focusing on a lot of things, you need to have a balance of say an exercise program or a program where you're involved in activities that are totally different from what you are really concentrating on. And I guess that is good advice that students can learn from that situation. what would you describe as your most effective method for studying and learning? Because that's always a key for any student. You know, normally we think about going to school and you have a teacher who will lecture or give a talk in class, and you learn as the teacher is explaining. But certainly the best student is one who can actually learn on their own and say go to a library and get a book and actually learn a subject from self-initiative. What would be your advice? Because that's sort of like the technique that you need to use in the university.
That's true, yeah.
Mm-hmm.
The best technique, there are several techniques which are quite effective. And I think it really depends on the person. So for me it always helped to combine it with some writing. So when I learn something, I would note down the most important things. If I fail to do so, I don't remember much, so maybe my memory is not that good.
Mm-hmm.
So a combination with writing helps, and I think it also helps to make breaks. You don't study. This is similar as with my research. So
sure.
I would concentrate maybe for 1 hour and then do something else and then again. And I also think a good schedule, a good plan
Mm-hmm.
for learning is important. And for me it is really not possible to study under big pressure, so I would try to have some plan. Mm-hmm. Start studying sufficiently early, and then you feel much better already, and you
don't
enjoy
pressure.
it much more. If you pressurize yourself
At the last minute,
yeah,
that's not a good technique.
I don't think
that's right. That's right.
It
It's stressful.
It may work for some, but it is not
it's stressful, and
exactly,
it could be counterproductive.
So, yeah.
So start early, have a plan, and
don't exhaust yourself.
write things down. Write things
this
down.
is for me.
And take frequent breaks.
Yes.
While you're studying. Those are great
and
concepts.
in mathematics, always think about why is it so. Mm-hmm. So just don't. If you have a theorem and you learn the theorem by heart, this is for nothing. You need to at least roughly understand the proof and get the feeling why is it so.
Okay, so why is an important question in math?
This is the most important question.
Most important question.
Yeah.
So when you say why, does that mean that you are thinking about a practical application of the idea?
No.
Okay, what is the
why?
why?
Is it true? A theorem is a statement.
Sure.
And just learning the statement by heart like a piece of law makes no sense.
Like a poem that you memorize.
Yeah. You cannot ask why.
Sure.
But in mathematics you have to ask why.
Sure.
Why is it true? And
give me an example of a why and then the answer to that why. Could you come up with a simple example?
With a simple example. For example, why is the sum of interior angles in a triangle equal to 180 degrees? You should not learn it by heart.
Okay.
You should just memorize the proof, which is extremely simple. Yeah, you just draw a parallel from to one side through the opposite vertex, and you see immediately all angles summing up to 180 degrees. This is then very easy to see.
Mm-hmm. You can visualize it.
Have at least the simple proofs or the essence of the proofs in your head. This helps a lot.
Mm-hmm. Yeah. Mm-hmm. That's a good tip for students. They ask the question.
Some
why.
students they really hate proofs,
mm-hmm.
and I think there are some very technical proofs which I would also not remember, but I know this is a very technical proof.
Right.
But good insights in proofs, I think this helps really a lot to memorize the whole thing.
Right.
And some logical chains from this result to the next and so on, because later in your research you have to do these chains yourself.
Mm-hmm.
You have a huge source of theorems,
mm-hmm.
and you should come up with a new one, right?
Mm-hmm.
With new results. So
right.
this reasoning, and so you need to learn. Actually, I took most benefit from those classes where the professor did not write down the complete proof, but just the main ideas of the proof. Because later on, when I studied for the exam, I had to complete the proof, and completing a proof by yourself is very useful.
Mm-hmm.
So
that really
gives you a deeper insight.
Gives you a deeper insight, and it actually trains your thinking along those lines.
Yes, exactly,
would you say that would be a key in mathematics in general that you have to learn the thinking process of proofs? Or would other branches of mathematics, it would not be that important, for example?
I think a proof is important in all branches of mathematics. Yeah.
Okay. So that's a fundamental,
It's very fundamental
key.
Yeah,
What are the tips in math in particular? Now, we were talking about studying in general. What other tips would you have for students about math in general as an important tool in many things that you can do in
but
the sciences?
it is at the heart of
Sure.
science and engineering.
Sure,
so
sure.
This is clear. Yeah.
Explain that role of math and explain tips that students can, since it's so important, is obviously something that any student thinking about a career in science and technology need to be very, very aware of the importance of them of doing math at a high level, to a higher point in terms of the type of math courses they should take and so on. What advice?
Well, again, it somehow this comes with the teacher.
Mm-hmm.
A good teacher will not just bring up some purely abstract problems. A good teacher would at least have some application, some reasoning, where is it important and why is it important there. This immediately increases the interest of the students.
Mm-hmm.
So I personally hate lectures which are in the old-fashioned mathematics style.
Abstract.
Theorem, proof, remark. Theorem, proof, remark, without anything else. This is terrible. Proofs are important, but motivation is also important.
Link it to the real world.
Link it to the real world.
Yeah,
You don't have, not for everything you need to have a fascinating application, but when it is really easy, and in most cases it's quite easy to come up with good relations applications,
Sure,
and
sure.
show it to the students.
That's
And
right.
students who are lucky to have such teachers are in a better situation. The others, I think now it may be easier with internet. You can have access to maybe very good material accompanying your studies in school, and they will find these relations, which at my time we had no internet. We just had this textbook, and if the textbook was good, we were in good shape. If it was bad, we were in bad shape.
Sure,
Yeah.
right. Were you always constantly
So
thinking?
personally, for example, linear algebra. This is one of the most fundamental concepts and subjects in mathematics, and almost everything you can solve actually boils down to some extent to linear algebra. You solve a linear system, you solve again a linear system, and so on, even for non-linear problems. Yeah? But when I had linear algebra at university, I hated it because it was really such a very abstract subject.
That's right. You couldn't tie it to
No,
reality.
not
Your
at
professor
all. No,
wasn't very good at tying it to reality, right?
No, it was so terrible that I hardly went into his lecture, but also the class materials, the course notes were similarly
Abstract.
abstract.
So when did you later realize how important it was and you gained an appreciation for it?
In geometry.
In geometry.
Yeah.
You
So
started
I
seeing
learned
the
it.
connection.
Yes, and then
Yeah,
I learned.
right.
the
So what is linearity? Could you explain it in a way that a student can
The students will know it. The students will know it.
No, but I'm saying for a young student out here listening to you now,
Now this is for very young students. This is probably.
is it going to be too difficult to explain that?
If you have never seen an equation,
Sure.
if you don't know the concept of an equation, but
Sure.
as soon as you have the concept of an equation, the students automatically start with linear equations,
Okay.
and they will see that some easy manipulations of one linear equation easily lead to a solution, and this can be extended to many equations,
Okay.
and this can be extended to really large systems of equations. And there is a theory behind all that, and this is linear algebra.
Sure.
It is also related to the analytical geometry. This is, if you use coordinates, and many things boil down to linear algebra.
Did you learn that in high school?
Sure, yeah.
Before you went to college?
Yeah, we had a very good teacher. We learned a lot in analytical geometry and some basic linear algebra I knew already. Yeah.
Because in many countries, as you might well know, they don't reach linear algebra until college.
I know, yeah.
And
then
even more advanced,
yes,
more advanced math, in fact.
Yeah.
And so your educational system would, really prepared you for high levels of math at an early age, actually.
It is the system, but it also needs to be the teacher.
Sure.
You could
Sure.
have a
Teachers.
I had a physics teacher who was really the opposite. So I know nothing about physics, almost nothing, which is a pity, but I almost nothing.
Right.
This is
Well,
due to the teacher.
well, it's not that you don't have the talent to learn it. You can learn it if you put your mind to it.
I know, of course, there are subjects which are quite close to geometry, but
right.
I should know much more.
Here's what are the most, this is a general question, what are the most significant breakthroughs in science that you predict over the next 10 years, or 25 years, or 50 years?
This is extremely hard to answer for a...
I know. That's why I asked the question.
This is for a mathematician, a geometer. I think it's extremely hard because we do not really have a deep insight into the forefront of certain technologies.
I'm not asking specifically about geometry. I'm just asking generally. Yeah.
I mean, there are fundamental problems which need to be solved, and these would contribute a lot.
For example?
Energy.
Okay.
Energy. Solves the food problem. I mean, these are the real problems, the big problems, and I think KAUST is really addressing these big problems. How do we feed people? I mean, this is much more important than reaching Mars or so with people. This is not so important. It's how do we feed the people? How do we solve the energy problem?
So
and anything that contributes to that. I'm sure that there is something out which will contribute.
How would you solve those problems?
I will never be able to solve them. I would put enough.
Well, you might have some ideas. I mean, sure, you have a creative mind, okay?
Yeah.
And you've demonstrated that very profoundly in your field. So obviously, creative minds can look at subjects that are not in their area of expertise and at least have a few ideas. That's why I asked the question.
Very hard. This is a really difficult question. If
I knew it, two things you mentioned. You mentioned energy and food.
Yeah.
So you must have thought about what could be done on those issues.
Well, the energy, I think that solar energy will be very important. Fossil energies will get less and less importance, and countries like Saudi Arabia are very lucky that they are also pretty, they have very good conditions in terms of exploiting solar energy.
Right.
So,
more sunlight comes in this country.
Because many poor countries are desert-like countries, but they may have access to solar energy, so maybe there is even a combination. So that especially those areas where the food problems are really big, if some big technological advance is made in solar energy, then this would solve quite a number of problems we have these days.
That might have some bearing on the food issue.
Yeah, absolutely.
Sure.
Yeah,
Exactly. Any other problems you see over the next 50 years in the world that we need to address?
I do not want to talk about the political problems. These are very big problems, of course.
Problems between countries and so on.
Yes.
We are thinking about scientific problems that can be addressed using science. That's
well, of course, also health, for example. Yeah? So then cancer. How do we treat cancer? How do we treat the major diseases which we cannot really treat now?
That's right.
And it is a fact that as soon as you can cure one disease, you are a medical doctor, you know much better. Others will come up with an urge, and so it's a continuous need to be active in this direction. And what else?
Well, here is the. Can you connect your work at all in geometry to solving any of these problems? What breakthrough would you anticipate in your field? I mean, obviously, that's a little different from, say, working in something in mechanical engineering or in another field where you're building something in electrical engineering. In math and geometry, a breakthrough might seem more how should we say, challenging, if you will.
I think
What would you anticipate as a goal of yours?
As a goal of my work
Sure,
here,
sure.
for me, I would really achieve my goal if I can open up a new direction for my research field by connecting it with some of the most advanced technologies which are around, like material science, nanotechnology, or things like that.
Mhm.
We have not been looking so far a lot into the microcosmos, but here we have the opportunity to do. We can go down almost to the atomic level and see that.
Mhm.
So finding structure there may be a really challenging thing, and analysis and understanding of experimental data. This is also something. If we can contribute to that, it would be big. And actually, we have also some ideas to start collaboration with the Solar Energy Center here, which we did not yet specify sufficiently detailed so that I could outline it to you, but I'm looking forward to start cooperation.
So, can you we'll get into the collaboration in a minute, but can you explain, you have sort of definitely gone into your areas of research a bit in the earlier part of the discussion, but can you explain your research and your field in a way that, say, a young student can understand, and so they can be motivated and excited by what you do?
Well, my field is, I would consider it geometric modeling, geometric computing. Anything you see here is basically consisting to some part, it is a geometric shape.
Sure.
And if it has to be manufactured, it has to be represented in a computer. This is already a large amount of tasks. How do you represent a shape in a computer? It could be for simulation, for production, in architecture, for example, the design is in the computer long before it is actually realized.
Of a building,
anything.
Of a monument.
So, for example,
KAUST, when they built KAUST, it was on the computer before it came to life as we see it now. Yes.
And so personally, I am currently I am most interested in these fancy new architectural designs and in ways to fabricate on this large scale, which is required in architecture, complex shapes. So not cubes and the simple traditional shapes, but really complex shapes. This is something which requires a lot of geometric understanding, and where really the architects nowadays, they use techniques that have been developed for car industry, for animation industry. They use these techniques for designing buildings. But then you can do it. You can bring it into the computer, but eventually you have to build it. And when you start building it, a lot of problems pop up. Because it's just very expensive. A car you will manufacture a car thousands of times, and you can spend
small scale compared to a huge building. Yeah.
You spend a lot of money maybe on a mold, but you use the mold again and again for the same model.
Exactly.
But in architecture, these big projects,
it's a one of a kind.
Exactly. So
and much more expensive and much more.
You need to find clever ways to manufacture.
You got to make sure that design that you have on the computer can work in the real world. Before you commit funds and commit a whole decision to go forward.
Yeah, so I find this an interesting. This was one of the motivations actually also to come to KAUST, because in this area in the Middle East there are a lot of projects which are in this direction,